day everyone, welcome to Teacher Facilitator Learning channel. For today's video, I would like to present to you Learning Physics as One Nation project. I got these materials including these video lessons last 2010 at Meralco Foundation when I attended the seminar training or workshop for this project, Learning Physics as One Nation project, and headed by the project leaders Sir Dr. Christopher Bernido and Dr. Maria Victoria Bernido. Sila po yung mga project coordinators of this Learning Physics as One Nation project. So this time in our discussion for vectors, I would like you to meet Dr. Maria Victoria Carpio as he teaches vectors. If you want to learn easily how vectors is being done, watch this video. At kung bago ka sa channel na ito, huwag mong kakalimutang mag-subscribe at i-hit ang notification bell on para maging updated ka sa mga susunod ko pong video lessons. Happy learning, everyone!
Our lesson for this period will be vectors in physics. Vectors in physics are very important, especially when we talk about forces, velocity, acceleration, and all the other quantities where direction will be important. Now, but before we talk about vectors, I would like you to remember what you have learned in your Science 1, first year high school, where you talked about what we call as scalars. Now, what are scalars? These are physical quantities which only have magnitude. So these are physical quantities which have only magnitude. Which have only magnitude. What does this mean? For example, we can look at a box. If you have a box like this, you were taught by your teachers in Science 1 that you can take the height, the width, the length, and the width. And you have your box. Okay? And the box will have the following measurements. So this is your box. Now we say that this is the height. So let's look at this. And we call this h. This is your height. You have this width. So here, let's call this W because this will be the width. On the other hand, you also have the length. So from this point to this point, let's call this L, where L is your length. So scalars are our physical quantities which have only magnitude, and we are looking at this example of the box, and I drew the box here to show the height. This is the height, and you have the length. This is the length, and the width, which we denote by the symbol W. Okay, now, when you look at the length, you did this in your Science 1, you can make a measurement. So for example, length L, if I use my ruler and measure it, I get 15 centimeters. So let's put 15.0 centimeters. And now you can also measure the width. So I measure the width and I get 10 centimeters. So width is 10 centimeters. And finally, we can look at the height of the box. So I look at the height and it's 8.0 centimeters. Now, when you make these measurements where you are only looking at different lengths, we say that these are just numbers. These are scalars, which have only magnitude. Now, how do we combine scalars? So, for example, let's ask the question, how do we combine scalars? When we say combine, that would mean, how do we add? So, addition. How do we subtract? You also have subtraction. And how do we multiply scalars? So, multiplication. So, just to review your Science 1, so for example, if you were to add, we can add length and width, and you would simply get the following. So, L plus W, and you put in the numbers, 15.0 centimeters, and you add the width, which is 10.0 centimeters, and you get simply the addition of just numbers 15 plus 10, so you have 25.0 centimeters. If I would ask you to subtract, on the other hand, you can also say subtract width from length, and you would get the following. You get length minus width, and you would get the number 15.0 centimeters minus 10.0 centimeters, and you would get 15 minus 10, so you simply have 5.0 centimeters. So, addition, you simply add the way you learned in your algebra in first year and second year. The same with subtraction. Now, how about multiplication? For multiplication, we can, for example, look at area and volume. So, let's have, for example, let's look at area. Then you can have length times width. This is area A. So, A is equal to length times width, and this is equal to 15.0 centimeters times the width, which is 10.0 centimeters. And again, you simply multiply 15 times 10, and so you get 150.0 centimeters times centimeters. You have centimeters squared. So this is how you would combine. Of course, you can also take the volume. Length times width times height. And again, you simply multiply the numbers and you multiply the units the same as you do in algebra. So this is an example of scalar, of a scalar. Area, you also have length, width, and so on. Now, another example would be for scalars. We can look at another example. Another example for a scalar. And that would be length of time or duration of time. Length or duration of time. And we normally use the symbol T for time. So you can say that you walk for 10 minutes, you run for 1 hour, and so on. So for example, you could have 2 minutes. You could also have 30 seconds. And these are all scalars. You can have 1 hour, and so on. I could be playing for 2 minutes. 2 minutes there would be time, and that is simply a scalar. Okay, now, it is very important for you to know how to work with scalars, how to add, subtract, multiply, and even divide scalars, because you will see that vectors are very, very different. So vectors are different from scalars. So here you are simply reviewing your scalars. Now, once you are very familiar with scalars, then now we can introduce our vectors. What are vectors? Okay? So, let me now proceed to vectors. Now again, remember, I keep on repeating this so you will not make the mistakes. Once you start working with both scalars and vectors, scalars only have magnitude. They are simply numbers like 15, 10, 20, and so on. On the other hand, let's look at vectors. What are vectors? Now again, I will ask you to remember what you learned in Science 1. Recall or remember. You learned about forces. Forces were defined as, or a force you learned earlier is a push or a pull. What do you mean by this? Again, we work with this box. I can push the box away from me, or I can pull it toward me. I can push the box to the right, or I can also push it to the left. I can move it upward and downward. So here you have, when you say push, this would be away from me or away from you. On the other hand, a pull will be towards you, towards me or toward me. Why do I emphasize this? Once you start saying toward you or away from me, away from you, to the right, to the left, that would mean that there is direction. So, here, you have direction in which a force is applied. So, It could be toward, it could be away, it could be to the right, it could be to the left. You could pull it upward, and so on. Another example. So let's call this example 1. Let's look at distance, which means simply a length. When you talk about how far is the wall from you, then you are talking about a distance. So this is just a length. You can measure it. Examples would be, you can have a distance, say, of 1 kilometer. You can have a distance of 3 kilometers. You can have a distance of, I just use d sub 3 to make it different from the others. You could also have a distance of 100 meters. So for example, a runner may be asked to run a distance of 100 meters in the 100-meter dash. Okay, now let's contrast this distance with what we call as displacement. Displacement now, so let's contrast with displacement. And in this case, displacement means coming from the root word place, and this, you say, this is a change in position. So, for example, I will walk a certain distance. So, I walk now to this point. And this point is about, from my position there to this position, the distance could be 1.5 meters. Now, I go back again to where I came from. So, what did I do? Suppose this is the floor. And you have somebody now who walks from point 1 to point 2, and say this distance is, as I said, 1.5 meters. After moving to this point, I return to the original position. Okay? So, from point 1, I walked to point 2, then back to point 1. Question: what is the total distance I covered? So, what is the total distance that I covered? Distance covered in going from point 1 to point 2 and back to point 1. Covered from point 1 to point 2 and back to point 1. Now, of course, you might probably say, I moved 1.5 meters to point 2, so 1.5 meters, and then I go back to point 1. So therefore, all I have to add would be point 1 to point 2, I cover a distance of 1.5 meters. On the other hand, going back from point 2 to point 1, again I travel or I walk 1.5 meters. And therefore, I simply add. And I get 3 meters. Okay. So this is the total distance. So the distance D is equal to 3.0 meters. This is the distance traveled. But now, if I were to ask you, what is the total change in displacement that I underwent? So if I were now to ask, what is the displacement or if I were to ask, did I change my position, then you would tell me that, but ma'am, you walk from point 1, I left point 1 and moved to point 2, but I went back to point 1, and therefore, the change in position is 0. So the displacement that I went through because I went back to the original position would be 0. Or no final change in position. So now what is the difference between distance and displacement? You have distance and displacement. Here, you simply measured distances or lengths that you cover. You get a meter stick and you can simply make a measurement. On the other hand, when you talked about displacement, which is a change in position, direction is important. So here for displacement, we say that direction is important. So just like force, which is your push or pull, direction is important. Displacement also, direction is important. So now we are ready to define vectors to distinguish between something which is only a number, like a distance or a length, to something wherein direction should be taken into consideration. Okay, so let me now define my vector. A vector or vectors are physical quantities which have both magnitude and direction. So I will underline this so you will always remember magnitude and direction. When you say magnitude, what do we mean? Magnitude would be, if you're talking about displacement, it will be the distance or the amount of, or the length that you cover. If it is a force, magnitude would mean how strong or how weak is the force. Okay? So, let me just write that down just so you will remember. So, magnitude, to understand this, if you have a force, this would refer to how strong or how weak the force is. If it is a displacement, magnitude would be the distance. Distance covered. Okay. Let me just complete this statement, is the magnitude. And of course, direction is quite easy to understand. Okay? So now our example, so indeed these are our examples of vectors. So I will just write down here examples would be displacement, force, and later on you will also meet velocity. Okay, so now you know the definition of vectors. In contrast to scalars, a scalar would have only magnitude, while a vector will have both magnitude and direction. Now, the next step is, so how do we represent vectors? Or what symbol do we use? Now, because they have magnitude and direction, then the most natural symbol to use would be the arrow. We use arrows to represent our vectors. So you could have a vector A. I could draw a vector as simply an arrow. The length of the arrow, so the length gives the magnitude of the vector. The magnitude of the vector. And the direction of the arrow will give the direction of the vector. Now, then I will call this now my vector A. The symbol used for vectors is the letter with an arrow on top, with an arrow on top. So here is my small arrow. So this is your vector. Now, let me just clarify things a little bit more. By the way, sometimes they also use bold-faced letters, bold font, for a vector. But we will not use that here in high school and on the blackboard because it will be difficult for you to differentiate bold from normal font. So it is better for us to use the symbol where you have the letter with an arrow on top. So once I have this means that my A is a vector quantity. So, for example, if I talk about the force, for the force, normally we would denote this with F, a letter F for example, with an arrow on top. Displacement would normally be denoted by letter D with an arrow on top. If I add two forces, say F1 and F2, then I would have F1 with an arrow on top plus F2 with an arrow on top. So please do not forget this, because once you take away the arrow, it becomes a scalar. And later on, you will see that vectors are really very different. The way we combine them will be different from the way we combine scalars. Now, but before we look at the combination of vectors, if I have a vector like this, we would like to be more specific about the direction. Now, for example, if I take this vector has length 30 centimeters. Okay, so length L equals, say, 30 centimeters. Okay. Now I take this vector will be the same even if I were to draw it somewhere here. I just have to make sure that the length should be exactly the same. Otherwise, I change the vector. So you have A. This is still my vector A. Now, the problem is, for a vector to be the same, you have to make sure that the direction is maintained. It should not change. Once you change the direction, if I were to draw this way, also the same length, this is not anymore the same vector. This is not vector A, but I can call it my vector B. Let me put down the symbol here. I will call it now my vector B. Why? They have the same length. So the length of vector A is 30 centimeters. And you see, I measured it. The length of vector B is also 30 centimeters. So we have the two vectors here. They are of the same length. As you see, when I took my ruler and measured them, length of A is 30 centimeters, length of B is 30 centimeters. But now we see that they are different vectors. Why? Because they have different directions. A is pointing in that direction. On the other hand, B is pointing in this direction. So they are different vectors. They are not the same. So in fact, we have to be very careful. When I said I am taking vector A and I move it and draw it here and I say that it is A, I have to be very careful that I do not change the direction of A. But of course, being humans, it's very difficult to tell whether I have changed the vector's direction or not. So, how do we solve that problem? We now have to indicate the direction of a vector. How do we do that? Here we will now use what you learned in geometry. Okay, let me erase this. So we will use geometry to make sure that we do not change the direction of the vectors even when we move them from one place to another. So we specify the direction of a vector by giving the angle, its angle with respect to a reference line. With respect to a reference axis or line. So for example, again, you have learned this in geometry. Suppose this is my axis, and I would like to indicate the direction of a vector. So I draw my vector here. Say this is my vector V. I put the arrow on top, while this is what I will call as my x-axis. Now the length of V will give the magnitude, but then I will now indicate the angle with respect to the horizontal x-axis. Then once I know my angle, I say that I know the direction of my vector. So if you have your protractor, what you would do, you have the protractor that you use in geometry to measure angles. So simply, if I want to get the angle theta, I get the angle, and this time my theta is, so this is 10, 20, 30, 40, 50. So here, theta is equal to 50 degrees. And therefore, if I go back now to my vector A, I want to transfer it, what I would do is make sure that if I get the angle of A with respect to the x-axis, so this is my horizontal axis, this is x, I measure the angle, so this is theta equals 45 degrees. Then, if I want to make sure that that is also vector A, I have to make sure that if I have my horizontal axis again here, I must measure the angle, and this should also be 45 degrees. Then I have the same vector. On the other hand, see, if I look at the direction of B with respect to the horizontal, I measure the angle of B, it is 75 degrees. So this is for vector A, this is for vector B, and as I measure with the protractor, it is 75 degrees. So even if they have the same length, they have different angles, they are different vectors. Okay? So again, the length of the arrow will give you the magnitude of the vector, and the angle will give you the direction. That's all you need to remember. Now, In physics, we will be also making use of reference coordinates. This is what we would do, especially for those of you who would like to be engineers, those of you who would like to be ship captains. It is very important for you to know how to find directions using vectors. So, let's see. You all know. Maybe I should use a longer meter. I have my vertical direction and horizontal. And I suppose you are familiar with this. Let me call this N. And going down would be S. N for north, S, south. And of course, as you expect, this will be east. While to the left, you will have west. So, north, south, E is east, and W would be west. We use this so that when we talk about displacements or change in position, then knowing this reference axis will make it simple for us. Okay, so for example, I will now give you some examples of displacements or vectors where you will make use of this. Let's say you want to go north. So I can say I can have my vector A is my displacement, for example, or a vector of length 25 centimeters and direction, I will say due north. What do I mean by this? Whenever you see the words due north, that would mean directly in the northward direction. So if I were to draw vector A, I would measure 25 centimeters. So here from 0 to 25. So from here, this would be my vector A. This one vector. Now another example. This time I will talk about, say, a vector B. Note that sometimes I use big letters, sometimes I use small letters. It doesn't matter. What is important is that you do not forget the arrow on top. That is very important. Okay, now let me see. Suppose now I have a vector B, but this is 15 centimeters. And this time I say due east. What would you do? So, in your activity, you have done this exercise. Due east, this is D-U-E. I hope that's clear. This is letter E. So, due east. Due east means exactly in the direction of towards the east. So, now I can draw my vector 15 centimeters. Directly on the axis. And this is my vector B. I hope this is clear enough. Let me just superimpose. Okay. Now, another example, something that you also encounter in daily life as you travel. Suppose now I have a vector C, and I say that it is 30 centimeters southwest. Now, by convention, whenever you see the word southwest, it would mean exactly 45 degrees between south and west. So I would measure 45 degrees. So here, 45 degrees would be and then I have to measure 30 centimeters. So I measure, this should be 45 degrees. And from your activity, you should be able to answer what would be this angle. But if this is 45 degrees, then the length is 30 centimeters, and this is my vector C. So these are examples. Another example, just so you will have something to guide you when you do your activity. Let me say now that I have a vector, let me have small e, the arrow on top, and this time, it is also 30 centimeters, but let me say it is 30 degrees east of north. What do I mean by this? East of north. When I say this, or when I write this down, this means that I will first look at the north direction, northward direction, and then I measure 30 degrees towards the east. Okay, so let's see. I start with the north and go towards the east 30 degrees. Okay, so now I measure. From the north, I have to measure 30 degrees. So 10, 20, 30, and my vector should be here. And it is also 30 centimeters. Again, I put my arrow tip, and this angle will be 30 degrees. And this is my vector E. So again, 30 degrees east of north, you start with the north and move 30 degrees to the east. Another example, F, say 20 centimeters, let's say 60 degrees south of east. Now, if you did your activity correctly, you will again start with the one at the right. East, you start with east, and then move towards the south 60 degrees. And that is what we will do now. So I start with the east direction, and I go towards the southern direction by 60 degrees. So I have 10, 20, 30, 40, 50, 60, and that would be my vector. And it is 20 centimeters long, and therefore it's only up to here. Okay? Let me transfer my letter B so you will not be confused. I will transfer this. My vector B is the orange vector. This is my vector B, orange vector. And now I am talking about my vector F, small f. And as I said, you start with the east direction and you move 60 degrees towards the south. So that would be 60 degrees south of east. Okay? So, now, this vector I can transfer, I can move and play around with this vector. The only condition is I should always make sure that the length is exactly the same and the direction is also exactly the same. It should always be 60 degrees. So if I were to move f, for example, move f vector, I can draw it provided, okay, if I have a horizontal axis here, I should move 60 degrees. So if I were to draw my vector here, 60 degrees, 10, 20, 30, 40, 50, 60. So I say that this vector is the same, but I also have to make sure it's 20 centimeters. Okay, so it's 20. So this is my vector F. This is also 60 degrees. So this vector F is exactly the same as this vector F, so I can move it around, I can move it here or anywhere. But two conditions, the length should be the same and the direction should be the same. You change the length, it's a different vector. You change the direction, it's a different vector. And in physics, it is very important that you maintain exactly, precisely the same quantity. So, let me just summarize again, because this is again very, very important. Because once you start doing velocity, acceleration, forces, then if you forget the arrow, for example, or you change the direction, then all your calculations will be wrong. And then you will get a very low grade. So it's very important that you make sure that you understand that a vector has magnitude and direction, and we represent vectors by arrows. The length of the arrow, how long the arrow is, will tell us about the magnitude of the vector, while the angle will give us the direction of the vector. Okay? So, the next question that we would like to answer would be, how do we combine vectors? So, how do we combine vectors? What do I mean by this? So, for example, I have different vectors here. I have vector A, E, B, F, C. Suppose I tell you now, add all these vectors. Add vector A plus B plus E plus F plus C. What would you do? Suppose, for example, here, I said, when you add two forces, F1 and F2, you say F1 plus F2. Would you know how to add these vectors? Now, you might think we will add them the same way we add scalars or numbers. But that's not correct. We add vectors differently. So, when you say combine, that means how do we add? Again, addition. You can talk about subtraction of vectors. You can talk about multiplication and its inverse, division of vectors. Now, for high school, you will only limit you will only be limited to addition and subtraction. If you're a regular high school here, you will only take up how to add vectors, and multiplication and division of vectors we will leave for college physics. Because there are two ways of multiplying and that would be quite complicated. So we only reserve this for college. For today, we will only look at the addition and subtraction of vectors. Now you will see that you have to be very, very careful because vector addition is very different. Okay? So I will not erase this because I will make use of these vectors here when we start adding. So these are your vectors, and later on we will come back to this. So I will move here, and I will now tell you how we add vectors. There are actually different ways, but for now we will look at the simplest way. So we have addition of vectors. Now for addition of vectors, we have what we call as the tail to tip method. Tail to tip method. This is the first method that we will look at, and it's the simplest. Why do I say that it is the simplest method? As you have done in your activity, this tells you, so when you add, to add vector, say A to vector B, draw vector A, so you will have the following steps. Step 1, draw vector A, and then your next step is draw vector B such that its tail connects to the tip of vector A. So let's see. I have vector A plus vector B. What is my vector A? It is 25 centimeters due north. So remember, I said that I can transfer this vector as long as I have the correct length. The length is 25 centimeters and it should be directly pointing northward. So I will follow this. I should draw vector A. So it is 25 centimeters directly north. So I draw my vector A. This is now my vector A. Okay, now I'm talking about tail and tip. The tail of the vector is of course this part, and the tip is the arrowhead. Okay, so this is the tip of the vector and this is the tail. Now, the next step tells me I should draw vector B such that its tail connects to the tip of A. So now I take vector B. Where is my vector B? It is this vector. And now I will transfer this vector and connect it to vector A. Now I have to make sure the length is correct. It's 15 centimeters and it is along the horizontal or due east. So I take vector B such that its tail connects to the tip of A. So let me use a different color so you will not be confused. So vector B should be along the eastward direction, 15 centimeters. This is my vector B. So you see, the tail of B connects to the tip of A. That is how I add the vectors. Now, what is the vector sum? The vector sum, so the vector sum is the vector from the tail of A, from the tail of A, the first vector, to the tip of the last vector, the tip of B. So again, the vector sum is the vector from the tail of A to the tip of B. So this is the tail of A, and this is the tip of B, and therefore I connect them, and this is my vector sum, and I will call my vector sum R with the arrowhead. I use the symbol R because the vector sum is also called the resultant vector. The vector sum is also called the resultant vector. That is why it is called R. Okay? So this is the tail to tip method. So when you are asked to add vectors, do not simply add, say, A plus B is equal to 25 plus 15 centimeters. That's not correct. You cannot add vectors the way you add scalars or simple numbers. Vectors behave differently. So now, the magnitude of R, I will write, I now get my ruler again and measure the length of my vector, and it is 30. I specify the direction. So again, I will make use of my angle mesh. My protractor is here. And the angle is 10, 20, 30, 40, 57. So this is 57 degrees. So theta of the resultant vector is 57 degrees north of east. From the east, I measure 57 degrees going to the north, and that is the direction of my vector. I will repeat because this is very important. To add vectors, do not add them like numbers. They add in a different, or they combine in a different way. The first method, the simplest method, is what we call as the tail-to-tip method. You take the tail of the second vector, connect it to the tip, and so on. And the resultant vector, or the vector sum, will be from the tail of the first vector to the tip of the last vector. If you have many vectors, you will simply do that for all the vectors. So let's look at this example. Let's see if you can add this. All you have to do is, let's see. So suppose now I will add 3 vectors. So another example. What would you like to add? Say, let's add vector C plus vector F. What else? Plus vector E. Now, if you are asked to find the resultant vector, what would you do? Again, we use the tail to tip method. You have, let's see, vector C. So I have a reference axis. Let me just have a reference. Vector C is 45 degrees south of west. So I measure 45 degrees south of west. So it would be here. And it should be, how long? Vector C should be 30 centimeters. Vector C is, no, this is not a good one. I'll use this one. Okay, 30. Vector C is 30 centimeters. Okay, and this is 45 degrees. Just make sure that I have the correct direction. Then I have vector F. What is vector F? Vector F is this vector of length 20 centimeters and angle 60 degrees from the east. So again, I draw my reference line just so I know that I should get the same angle. And I will connect to the tip, so I take, what's the angle? 60 degrees. 10, 20, 30, 40, 50, 60. It's here. And the is for vector F is 20 centimeters. So 20 centimeters. Okay. This is my vector F. Again, we have followed the direction. The tail of F should connect to the tip of the first vector. Next vector, vector E. We will add vector E. Vector E is 30 centimeters long and the direction is 30 degrees east of north. So again, this time I look at a vertical reference point. That's how I will measure my angle. And I'll get a different color. So vector E should be 30 degrees east of north. So I get my protractor again. 10, 20, 30. Okay? And it should be, how long? 30 centimeters. So 30 centimeters also. So this is 30 degrees, while vector F, this is 60 degrees. Okay? So, I hope that's clear. Let me just make sure this is clear. So, you have here vector C plus F plus E. Using the tail to tip method, I take the first vector C, make sure I have the correct length. This is vector C. Length should be 30 centimeters. Now, I take the second vector, the tail to the tip, and then I take the third vector, connect again the tail to the tip. What is the vector sum? The vector sum will be from the tail of the first vector to the tip of the last vector. So I get this. Don't think it's coming out. So here is my resultant vector. This is my R. This is the vector sum or resultant vector. The length of R is 14.5 centimeters. So is 14.5 centimeters. And the direction, we measure the angle from the horizontal. I can use this as my reference. So this is, where is it? So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Or it's better 10, 20, 30, 40, 50, 60, around 62 degrees. So theta is 62 degrees south of east. Again, I measure from the horizontal. I measure this angle. So 10, 20, 30, 40, 50, 60, around 62 degrees. So this is your theta. This is your vector sum. So now you can do all the other activities, try to exercise, and remember, it is very important that you keep the correct length and the correct direction, especially when you are making use of the tail to tip method. If you make a mistake, you'll put this as 40 degrees. That is already a different vector. So here on the blackboard, it's more difficult for me because the chalk is thick. But on your paper, on your activity sheets, make sure you use very fine pencils. Then you will have a very accurate measurement of your vectors. That is how you will add vectors. By the way, you notice that when I talk about the magnitude of the vector, I simply write the letter R without the arrow. That is the convention that we use. Whenever you have a letter without the arrow, that is simply the magnitude of the vector. Once I put the arrow, it is a vector, then I also have to have the direction. So this is now the magnitude and this is the direction of the vector. Okay? So far, we have talked about combination of vectors in such a way that we add them, addition of vectors. So, vector C plus vector F plus vector E. Or you have vector A plus vector B. You add two vectors. Now, how do we subtract vectors? So, this time we will subtract vectors properly. Let me see. But before that, we should first know that, okay, let's see, subtraction of vectors. Now, from elementary, you know that addition is the inverse of subtraction, or subtraction is the inverse of addition. Now, the same way with vectors. Suppose I would like now, instead of A plus B, I wish to have A minus B. So again, I take this vector A, and I would like to subtract vector B. In my example there, here, I added A, vector A, plus vector B. So this is how we did it using the tail to tip method. Now, I ask the question, can we also subtract vector B from vector A? This is how you will do it. A minus B is nothing but, as you have learned from algebra, the inverse of addition, this is just A plus the negative of B. So subtraction is just like addition, but you have the negative of the vector. Now, what do you mean by the negative of the vector? So this is what is important now. The negative vector is equal in magnitude but opposite in direction. But opposite in direction. So for example, let's look at vector B again. Vector B is 15 centimeters due east. So vector B, I have 15 centimeters due east. This is vector B. Now, what is negative of B? The negative of B is exactly the same vector except that it is now in the opposite direction. So also 15 centimeters long, but towards due west, in the opposite direction. So this is negative of B. I repeat, given any vector, say vector B, I want the negative of the vector, then it is simply in the opposite direction. Same magnitude, opposite direction. And therefore, we can now subtract B from A. What do? We simply add the negative of vector B. So let me do that now. I take vector A again, using the tail to tip method. So I take vector A. Where is vector A? It is this vector, 25 centimeters due north. So 25 centimeters due north. This is my vector A. And now, using the tail to tip method, I take the second vector, connect it to the tip of the first vector. Okay, what is negative B? Negative B now is in this direction. Let me move my symbol so that my drawing should be clear enough. So I take vector B, 15 centimeters due west. So now it's in the opposite direction. This is negative B. What is the resultant vector or the vector sum? Again, the vector sum is simply the vector from the tail of the first vector to the tip of the last vector. So I simply connect. This is my vector R. This is my vector sum. And again, the magnitude R is equal to, let me measure, I have 30 centimeters, and my direction, let me see my reference point there. It is with respect to the horizontal. So if this is the horizontal, or this way. Let me see. Do it differently. 10, 20, 30. 30 degrees west of north. Or if you wish, it is from the horizontal, then it would be 60 degrees from this angle. Okay? Let me see. If you want it to be from the horizontal, let me see. Should be okay. I should be more accurate. I'm measuring the angle. It should be this is around 32 degrees west of north, or 57 degrees. This angle is 57 degrees north of west. This is how you subtract vectors. You simply add them the way you know how to add them. The only difference is that whenever you subtract, you add the negative of the vector. What is the negative of the vector? It is the same vector, it is a vector equal in magnitude to the vector but opposite in direction. That's all. And then you can proceed. Now, let me now comment on something here. I worked with A minus B, and there I worked with A plus B. A plus B, and some of you may have noticed that you don't get 90 degrees. This, when you add this, you have 89 degrees, while there you get 87 degrees. Whenever you have complementary angles, normally you should have the same. You should get 90 degrees. Some of you may have noticed that. And in fact, that is what I would like to emphasize now. What we have done is to apply the tail-to-tip method. This is drawing vectors. You take a vector, you know its length, you know its direction, you simply draw the vector with your pencil, or for me it's the chalk, which is of course very bad because it's not accurate. And so you see that the tail-to-tip method is not a very accurate method. You can make mistakes. Like the chalk is quite thick and therefore my measurements may not be very exact. You on your seats with your pencil and ruler will probably get better measurements than I do. So you may now ask the question, is there a better way to add vectors? Of course, there's a better way. It is what we would call now as the analytic method. Now let's look at another example when you're playing with vectors, addition of vectors. So again, this would be addition of vectors, but example 2. Now suppose, let's look at the problem. You could have a game, somebody is playing baseball. Suppose a runner goes through a path shaped like a parallelogram. Parallelogram. Now, this is from your geometry, 3rd year. What is a parallelogram? A parallelogram is a polygon with 2 pairs of sides parallel to each other. So, you could have a runner. So, let's see. We describe it this way. First, he goes through displacement d1. Let's say 50 meters due east. Then he, from 50 meters due east to another point, then he goes through another displacement, say 30 meters northeast. Afterwards, he goes through another displacement, 50 meters due west. And finally, the runner goes through another displacement. He goes 30 meters southwest. Let's just look at, let's try to draw the vectors, and let's have a scale of, say, 1 cm centimeter is to 1 meter. So this means that for every centimeter, I get 1 meter. Therefore, if I have 50 meters, I can draw my vector as how long? 50 centimeters. Okay? So now I go due east, say from one point here, I measure 50 centimeters. This is 30, so I have to add 20 to this point. So this is D1. And now the next displacement is 30 meters northeast. Do you remember what I mean by northeast? Whenever we have just northeast, that means it is at an angle of 45 degrees from the horizontal. So let me just make sure I have my angles correctly here. And I draw my D2. It should be at 45 degrees northeast. So northeast, it should be 45 degrees here. And the length would be 30 centimeters because it's 30 meters, so it should be 30 centimeters. So this is now your vector D2, the displacement. Next, so we have done D1, we have done D2. Now we look at D3. For D3, it should be 50 meters now due west. So it will now be in the westward direction. And 50 centimeters. So again, it should be horizontal but to the left. 50. 30 plus 20. So this is D3. And finally, we look at D4. It is 30 meters southwest. So again, we measure the angle. Let's look at the coordinate axis here. It should be southwest. So this is south, this is west. We should measure 45 degrees here. So it should be 45 degrees. So again, this would be 10, 20, 30, 40, 45. And it should be 30 meters. On our scale, it will be 30 centimeters. This is your D4. And so, the question is, what is the total displacement of the runner? What is, so you have here, suppose a runner goes through a path shaped like a parallelogram. What is the total displacement of the runner? And as you see, I gave you the values here. We simply followed using the tail to tip method. First vector, D1. Then I add D2, so the runner goes from this point to this point. Then from this point to this point. Then westward, and finally southwest. What is the total displacement of the runner? Now, if you did your activity and if your answer is 0, you are right. Because, remember, this is the point where it started. The total displacement, because the runner just went back to the original position, the total displacement or vector sum, the total displacement or vector sum d1 plus d2 plus d3 plus d4 is just 0 or the 0 vector. So there is no total displacement. But if I were to ask you, what is the total distance traveled by the runner? What is the total distance covered or traveled by the runner? Now, distance is just a scalar. Since distance is a scalar, we simply add the magnitude of the displacements. So this is a scalar, so we simply add d1 without the arrow. So be very careful without the arrow, plus d2 plus d3 plus d4, and this is equal to, substitute what is d1, just the magnitude. This will be 50 meters plus d2 is 30 meters, d3 is 50 meters, and d4 is 30 meters. And therefore, you simply add 50 plus 30 is 80, plus 50, 130, plus 30 is 160. So this is 160 meters would be the total distance traveled. That is because the runner, that's why the runner maybe feels tired, because he ran all the way from this point to this point to this point to this point to this point. But when you talk about the displacement, a displacement is a vector. It is different from distance. Then the total displacement is 0. So I hope you have seen the difference between the vector and a scalar. A scalar, you simply add. They are just numbers. But vectors, you have to be very careful. But you can choose the tail-to-tip method, or you can choose the component method. So this is your example. Now, just as a brief summary of your examples of vectors, now that you see the difference, here you have the vector, and here you have a scalar. So let's just have a table, because you will be meeting all these physical quantities. Okay, so you can have displacement is a vector. Just label this. Okay. Displacement, on the other hand, distance is a scalar. Now you will also meet velocity while the magnitude of the velocity, which is just the speed, will be the scalar. You will also have force. For example of a force is the weight. What is the weight of an object? That is a force. On the other hand, mass or the amount of matter is a scalar. And we have to be very careful when you are working either with the scalar or the vector. Later on, you will also meet acceleration, which is the change in velocity, as well as other forces, other vectors, for which you will be using all these techniques in addition of vectors.